Hello everyone, this is Dnyaneshwar Sanap, working as an assistant professor in the Department of Chemistry at Maratha Vidya Prasarak Samaj, Arts, Commerce and Science College, Dindori. In this video lecture, we will discuss about the molecular orbital energy level diagram for B2 molecule. B2 molecule is made up of two boron atoms. To understand how the B2 molecule is formed, we have to first of all understand what is the electronic configuration of each boron atom which is participated during the formation of B2 molecule. Let us see the electronic configuration for the first boron atom. The electronic configuration of boron is 1s2 2s2 and 2p1. There is two shells in which the electron is present in the boron atom. First shell, that is K shell, and second shell, that is L shell. The K shell is inner shell and L shell is outer or valence shell, which is participated in the bonding. Similarly, the electronic configuration for the second boron atom also 1s2 2s2 and 2p1. The L shell having 3 number of electrons which is participated in the formation of molecular orbitals. Let us write this valence shell electron in tabulated form for the both atoms. 2s2 and 2p1 for the first atom. Similarly, 2s2 and 2p1 for the second atom also. The total number of electrons which is participated during the formation of B2 molecular orbital is 6. Let's start the drawing of molecular orbital energy level diagram. First of all, we have to write the atomic orbital of valence shell of each boron atom in increasing order of energy, one by one. The first atomic orbital of first boron atom is written like that: 2s having 2 electron and 2p having 2 electron. 2p including 2px, 2py and 2pz atomic orbital. At same energy level, we have to write the atomic orbital of second boron atom respectively: 2s2 and 2p1 like that. When this 8 atomic orbital combines together, it produces an 8 molecular orbital like that. The number of molecular orbital is produced is equal to the number of atomic orbital participate in the formation of molecular orbitals according to the linear combination of atomic orbital principle. When 2s atomic orbital of both atoms combines together, they produce the 2 molecular orbital. Out of these 2 molecular orbital, one is bonding molecular orbital which is lower in energy and one is anti-bonding molecular orbital which is higher in energy with respect to the 2s atomic orbital of both boron atom. Similarly, when 2p atomic orbital having 2px, 2py and 2pz orbitals when combines together according to the LCO principle, it produces an 6 molecular orbital. Out of this 6 molecular orbital, 3 molecular orbital which is lower in energy called as bonding molecular orbital. It may be including sigma bonding molecular orbital or pi bonding molecular orbital. Similarly, it produces the 3 higher energy molecular orbital which is called as anti-bonding molecular orbital. Out of these 3 molecular orbitals, 2 is pi star antibonding molecular orbital and 1 is sigma star antibonding molecular orbital. Let us see the nomenclature of each molecular orbital one by one. The lowest energy bonding molecular orbital which is formed by the combination of 2s atomic orbital called as sigma 2s and higher energy antibonding molecular orbital which is produced by the combination of 2s atomic orbital called as sigma star 2s molecular orbital. Similarly, the molecular orbital which is produced by the combination of 2p orbital is the pi 2py and pi 2pz which is degenerate in energy, and sigma 2px which is higher in energy than that of pi molecular orbital, and higher energy antibonding molecular orbital respectively pi star 2py and pi star 2pz orbital as well as sigma star 2px molecular orbital. During the formation of B2 molecule, the energy gap between the 2s and 2p atomic orbital is very less. That's why there is interaction between the 2s and 2p orbitals and their electrons, and that's why whatever sigma 2px orbital, which is higher in energy than that of pi 2py and pi 2pz molecular orbital, as we see in the case first in the previous some videos. The next point is filling of electron in molecular orbital from the respective atomic orbital. There are total 6 electrons which is present in the both atomic orbitals, which is filled one by one in the molecular orbital according to the above principle and Hund's law of maximum multiplicity. According to the above principle, the first electron goes to the sigma 2s bonding molecular orbital. Similarly, second one, the sigma 2s molecular orbital having no tendency to accept the third electron in it. That's why third electron by default goes to the higher energy, that is in sigma antibonding molecular orbital. Similarly, fourth electron also goes to the sigma antibonding molecular orbital. Remaining 2 electrons in the 2p orbitals of both boron atomic orbital is filled in the pi 2py and pi 2pz molecular orbital respectively, according to the Hund's rule of maximum multiplicity. According to the Hund's rule of maximum multiplicity, there is no pairing of electron in the degenerate atomic or molecular orbital if each orbital having at least one single unpaired electron in it. After complete filling of at least one electron in each degenerate orbital, after that pairing of electron is take place, and that's why there is presence of 2 parallel spin single electrons in the pi 2py and pi 2pz molecular orbital. From this diagram, we are conclude to writing the electronic configuration for the molecular orbitals of B2 molecular orbital energy level diagrams. Let us write the electronic configuration for the molecular orbitals in the increasing order one by one. Before start the writing the electronic configuration, we have to keep in mind there is 1s atomic orbital which is present in each boron atom, which does not take part in the bonding, and that's why for both 1s atomic orbital we have to write the capital K twice. After that we have to write the increasing order of molecular orbital with the number of electrons present in it on the parenthesis, like this: K sigma 2s to 2, sigma star 2s to 2, pi 2py 1, degenerate with the pi 2pz 1. This electronic configuration is in the increasing order of molecular orbitals. The next point is calculation of energy evolved during the formation of B2 molecule. Basically, energy evolved for any molecule is calculated by using the formula the number of electrons present in the bonding molecular orbital into minus beta plus the number of electrons present in the antibonding molecular orbital plus beta. Let us put this value of number of electrons present in the bonding molecular orbital and antibonding molecular orbital for B2 molecular orbitals respectively in the formula. We get this equation: 4 into minus beta plus 2 into plus beta, because these 2 electrons in the sigma bonding molecular orbital and these 2 electrons, that is total 4 number of electrons which is present in the bonding molecular orbital, and this 2 electron which is present in the antibonding molecular orbital. After solving this equation, we get the values of minus 2 beta, that is the stabilization energy which is evolved during the formation of B2 molecular orbital. The next point is calculation of bond order for the B2 molecule. The bond order is calculated by using the formula number of electrons in the bonding molecular orbital minus the number of electrons in antibonding molecular orbital divided by 2. After putting the number of electrons available in number of electrons present in the bonding and antibonding molecular orbital respectively, we get the equation 4 minus 2 divided by 2 is equal to 1. That means there is formation of net 1 bond in the B2 molecule. That means the molecule is exist. The next point is stability of molecule. According to the energy evolved and The bond order. Number 1. The molecule is exist, but the B2 molecule is exist in the vapor state. Next point is magnetic property. Basically, magnetic property is depend on the number of unpaired electron in the molecular orbital energy level diagram. In bonding molecular orbital, there is 2 electron which is unpaired in nature in the pi to py and pi to pz bonding molecular orbital. That's why this molecule is paramagnetic in nature. Thank you for watching.